everyone. How are we? My name's Savannah. I am the program lead here at the Macquarie University Incubator. Welcome. Thank you so much for joining. We're really excited for the session today. We have Dr. Ines here to speak to us today. So before she kicks off, I'm just going to tell you a little bit about her and her background. Dr. Ines stands at the forefront of the philosophy of mind and cognitive science of AI. She's renowned for her insight into fundamental questions surrounding agency and intelligence. She's an assistant professor here at Macquarie University and is also a researcher at the Macquarie Ethics and Agency Research Centre. She's got a really solid foundation in academia, and her transdisciplinary approach allows her to bridge the gap between different sectors, fostering meaningful dialogues and collaborations that address complex societal challenges in the AI era. Notably, Dr. Hipolito also founded the International Society for the Philosophy of Sciences and the Mind, demonstrating her commitment to the advancing field and fostering scholarly exchange. Additionally, as if that's not enough, she's also the founder and CEO of Mission AI, which is one of our startups here at the Macquarie University Incubator. She works also in an ethics-based role at Versus, a Los Angeles-based cognitive computing company, and she leads initiatives aimed at promoting ethical AI cultures and responsible implementation practices. Before Ines chats to us today, we're just going to pause for a quick acknowledgement of country, and then I'll invite her up.
Welcome. We acknowledge the traditional custodians of Macquarie University land, the Watamatical clan of the Darug Nation, whose cultures and customs have nurtured this land since the Dreamtime. We pay our respects to elders past, present, and future. We welcome people of all nations and all faiths. Waibidja, Jauna Payala Jaungi. Come here, we speak together. We have 60,000 years of archaeological evidence of Aboriginal habitation at Lake Mungo and 20,000 years in Ryde. We have great antiquity. Today, hundreds of Aboriginal and Torres Strait Islander people graduate from Macquarie University. The Darug Nation had famous leaders such as Chief Yarramundi, Narrabinji, Hulby, and Maria Locke. The descendants of these Darug people live today amongst you. We celebrate with you our ongoing attachment and custodianship of this country. We celebrate the achievements of Macquarie University.
Thank you. I'll now welcome up Dr. Ines.
Thank you. Well, yeah. It's always a little bit tricky. Oh. Should go back one slide. There we go. Yeah, it's always a little bit tricky.
Sorry, we're all
perfect.
A bit of a fight with
yes.
Aren't we? There we go.
All right. Hello. Hi, everyone. I'm very, very happy to be here talking about this today. And what's going to happen is I'm going to cut down through the hype on AI and see if we can deal with that AI FOMO. Right. Okay, so the first part is how does AI work? Second part, I'm going to go through the bursting the bubble, cutting through the hype. Do we really need AI? And then third part, how to use it well if we actually end up thinking that we don't need it. All right, so what words would you associate, just never mind the QR code for now, because we have online. So what word would you associate with AI? Intelligence. Computer. Pardon? Automated. Yes, automated. Armageddon. Not a bad one. Yes. Generative? Okay, very good. Yes. Language. All right. Fear. Okay. Okay. Yes. And robot. All right.
Offline, we're getting disruptive, sentient robots, the future, artificial.
Interesting, isn't it? Because some of our words are going to the very technical properties of it, aspects of AI, and others have to do with humanities, right? And that's exactly where we want to be, right? We want to be in that right interface between the technicality and the humanities, okay? Right, so let's just move on and think now about something that we are all familiarized with, which is ChatGPT. What word would you associate with ChatGPT? Pardon? Writing good copy. What else? Prompt. Database. Any other words? Yep. Efficiency. Okay. What else?
Online, we're getting conversational assistant.
Conversational assistant. Anything else? Productive. All right. So keep these words in mind, okay? Because some of them, maybe most of them, we are going to destroy them, okay? I'm going to try to convince you otherwise, okay? And then let's see how it goes by the end. All right, okay, so let's just first locate where these things are, right? Let's just go through a little bit of definition and understanding what things like ChatGPT are and where they live technology-wise. So we have a mapping here of artificial intelligence, and they have different technicalities that we don't really need to worry about. But many of the words that you mentioned, they live here. The ones that were technical, they live somewhere in this map. And then I located that white dot over there because it's more or less hard to tell, but it's more or less where our large language models or generative AI lives, right? And what I wanted to do with you is like the first part of the talk is just to really guide you through all of these words, generative AI, large language models, ChatGPT, how do they relate with each other, right? Okay, so then we have this kind of map here, right? And what happens here is that we have something called large language models. And this is just literally technicality that I'm gonna come back to it. But for you to have an idea on how these things map, what we have is we have some kind of like things that we can produce when we engage with large language models. We can do text generation, embeddings, classification, knowledge answering, speech recognition, language translation, dialogue generation. These are kinds of things that these apps related to or coming from large language models allow us to do. And then we have many different ones. The one that is the most famous one, I would say, ChatGPT, but then it's not the only one. We also have other ones coming from Meta, and as you can see, there's a variety of then companies that are developing these large language models, OpenAI being the one that is behind ChatGPT. And then we have technologies associated with it. So this is just to have a little bit of like the landscape of where these things live and how they connect with each other. All right, so now as we want to define and go and make our way from generative AI to large language models to ChatGPT, so that we kind of like make our way towards what we are mostly familiarized with, which is ChatGPT. And I know that many in the room already have quite an idea of how these things work, but let's just go over it for those that who actually don't. So generative AI is this type of intelligence that is designed to create new content. That's where generative words comes from. It generates new stuff, new content. And this can be text, images, music, code, and it is based on what it has been trained on, okay? On the databases that it has been trained on. Its function is it uses algorithms and models to generate original content that mimics human created work. And the keyword here is human mimic. That's the keyword, okay? Because this is the point that I really, really wanted to come across, is what is the main goal of any large language model? It's to mimic, right? It's to mimic a human having a conversation. That is the whole point. So keep that in mind. So some examples, like we said, ChatGPT, DAL-E, JukeDeck, and many, many others. So it allows us to create content. So content creation, like writing articles, creating artworks, composing music, those kinds of things. It also allows us to do something like more than automation, like more like kind of like augmentation kind of task, like by generating synthetic data for training other AI models. It also allows us to have some kind of like creative assistant where it allows us or assists us in brainstorming and ideation processes. Some of you in the room here are researchers, and I am sure that you, as I have, played around with it and see how it comes up with a research project idea for ideation and brainstorming and that kind of thing. So that would be it. And then the technologies involved, for those of you who are more tech savvy, neural networks, particularly deep learning models like generative adversarial networks and variational autoencoders. These would be the technologies that are involved. Now, how do they really work, right? Let's go a layer deeper. So they work as a statistical model creation, right? So what they do is they build this vast statistical model from these kinds of things that is almost like they live in a cloud of knowledge, right? So this kind of extensive internet source text data, right? So it's like things that live in a cloud in the digital space. And they have this minimal human input, us giving a prompt. And then the model forms autonomously with limited human intervention using nodes as probability functions for word occurrence, something like what you get here, right, in a very simplified version of it. So then they are trained through prediction, which means that the system learns by predicting the next word in sentences and adjusts based on feedback, right? So what's the keyword here, or the keywords, or the key idea? Pardon? Learns. Adjust, feedback, predicts the next word. That's it. Remember what we said earlier. What's the main goal of a large language model? To mimic, to seem like it's a human that is interacting with us, right? How does it do that? By predicting next words, okay? So that's what's happening. All right. So then how does it do that? This gets a little bit more technical. Each word is associated with a vector in a high dimensional space, something like this, positioned by context similarity. And here there's a concept that comes up, which is called a context window. A context window is the context, the limitation or boundaries of the topic that we are asking or engaging with the LLM to tell us and talk to us about it. That's a context window, right? Okay. So that's a contextual understanding for the model to do whatever it is that we ask the model to do for us, right? So the model interprets a string of words, creating vectors that represent the meaning and the context. Does the model understand any meanings? Yes? So if we go back to it predicting the next word within a context window, which is a topic kind of thing, right? So then the model doesn't really understand meanings, right? It's just predicting the next word that will come with the words and within the context window. Okay, so then word selection. It calculates likelihoods for subsequent words, choosing among the most probable, but not always the highest. It's just the most probable, and it's not the highest. And it may also not be the most correct one. It's the most probable. What does that mean? It means that in this database, in this monolith of a database that we have that lives in the past, it was the most probable word that came with that within that context window. That's all that it means. Something that is information that lives in the past. Okay. Right, so then what are the limitations of large language models? Limitations are in truthfulness, So what this means is that we already mentioned this, but it is worth that we really keep these ideas. Large language models aim to generate plausible sounding text rather than factually accurate information. Exactly, doesn't it? Yes, it does sound like a politician. And it's going to sound like way worse than that, if you can imagine. So what they're here to do is to sound very much like us rather than giving you facts. So the real world consequences of this are many, but I've got just two for you here in this particular slide. In judicial critique, judges have noted that there are texts filled with non-existent judicial decisions and citations. So this is in law and courtrooms. In academic testing, so what we find is that large language models can create seemingly comprehensive texts, but they fail to provide real evidence. And then this is going to have implications everywhere. This is going to have implications to anyone that integrates AI in whatever it is that they're doing, right? Or in the services that they provide, or us as users, right? I will come back to this. Then there's also going to be something that is now getting to known in the literature as the snowball effect, which is large language models, when confronted with errors, when we turn to them and we say, well, that's quite not right, is it? They would go into this snowball effect. And that's by building upon false claims without self-correction. Okay? So then we have something that has come up in the literature as this AI hallucination. And what this means is that they may hallucinate sources and facts, and they do hallucinate sources and facts, leading to inaccuracies in the generated content. So if anyone in the room is aiming to interact with these large language models to generate knowledge, right? So hallucination is going to be an issue, a live issue that we really need to take and consider very, very seriously. And then there's also the technical and popular recognition that the issue is acknowledged in both technical documentation and media reports. So we can find that these have been the findings and the live issues that we find not only in research, but also in media reports. Right, so then because remember, what is the main goal of a large language model? Mimicking a human speaking, right? And how does it do that? Predicting next words within a context window, right? So because of that, what happens is literature has come up and said, well, a better way to look at it is through the metaphor of large language models being like calculators for words. So make no mistake, that's what they do. They are calculators for words, right? So then let's see what they say. So Wilson says, one of the most pervasive mistakes I see people using with large language model tools like ChatGPT is trying to use them as a search engine. I like to think of large language models like ChatGPT as a calculator for words. Want them to work with specific facts, paste those into the large language model as part of your original prompt. So he's arguing for the view of thinking about ChatGPT and large language models as calculators for words, right? And it could be an interesting and useful way of communicating this, because our job is to communicate to the public, communicate to our students, communicate to our researchers what these large language models are, what they do, and what their limitations are. So maybe this metaphor as calculator for words is quite straightforward and helps us immediately capture that understanding of what they actually are doing, calculating the next word. So there are some reasons in which we could agree that a ChatGPT or a large language model could be seen as calculators for words. Now, some of the limitations of thinking about it as calculators for words are that they use false information. So AI bots can produce misleading information or slanderous content, as you can see, for example, in these two papers. Beware of artificial intelligence hallucination, or should we call confabulation? We'll get back to this. ChatGPT and BART exhibit spontaneous citation fabrication during psychiatry literature research. So the term hallucination is used in academic literature to describe AI mistakes, and controversial as it humanizes AI models, right? So what this means is that some people are using hallucination to describe what ChatGPT is doing. The issue being that may lend us to think about these large language models as having some kind of like human feature, because an hallucination is something that we humans do and not machines, right? So there's a little bit of pressure on that conceptualization. An alternative term comes up as confabulation, right? And the confabulation is suggested by Ben Edwards as a better metaphor than hallucination, because it acknowledged that, even though it acknowledges that it is not a perfect term, but at least it's trying to get at to dehumanizing the technology and the machine, right? And there are consequences of these kinds of errors, because there are, of course, implications to whether we use it as hallucinations or confabulations. The point being that the ways in which we are conceptualizing ChatGPT, large language models, as we communicate to each other to understand what they are and their limitations, are really, really important, because it's going to inform the ways in which we interact with it personally, and also how do we allow them, these systems, and integrate these systems within the things that we are doing on a larger scale, on a community scale, on a business scale, right? So it's really important that we get this conceptualization right. So we were coming from saying that, well, maybe we can communicate them as calculators for words, right? So the issue here is that calculators do not hallucinate, and they do not confabulate. So calculators for words does capture that aspect that we really want to get at, the prediction of next word within the context window. It does capture that, but it misses out on the other aspects, which are the facts that there is a space where these systems are confabulating or hallucinating, right? So there are some warnings coming up in generative AI applications for unexpected and problematic in academic searches due to potential fabricated information. So we already covered that a little bit. So we have in the literature, artificial hallucination in ChatGPT, implications for scientific writing. Another paper that is not here, but should be, is a paper that is very recent by Nature, and it calls up on the fact that using large language models for science will end up or producing a monoculture science, which for those researchers in the room, I will strongly recommend reading that paper. How large language model hallucinations can snowball. So we already touched upon this topic, and I just wanted to unpack that a little bit more. When asked to produce evidence for its claims, it provided 5 references dating to the early 2000s. None of the provided paper titles existed, and all provided PubMed IDs were of different unrelated papers. This is very common for those of you that are researchers. This is very common that we come across this. So those errors can snowball when the language model is asked to provide evidence for a deeper explanation of a false claim. It rarely checks itself. Instead, it confidently produces more false but normal sounding claims. Because let's go back to it. What's the main goal of a large language model? That mimics, that sounds like a human. What is not the business that a large language model is at? Fact checking, giving me facts. That's not a large language model business. They couldn't care less, or it couldn't care less, right? It's to mimic and sound like a human. That's what they want to do. That's the goal. Okay, so then we have, this is a very recent paper just out like 2 days ago. So now it moves on from, well, maybe ChatGPT and large language models are hallucinating. Oh, we don't really like that conceptualization because it kind of gives us a sense in which it's a human, like we are anthropomorphizing the system. We don't like that. So maybe it's confabulating. Well, but maybe that's still too much of humanizing. So now we have this paper just out, right? So that goes a little bit to what you were saying earlier, that maybe large language models are like politicians. Maybe it is just bullshit. So these errors, they tell us in this paper, these errors are pretty minor. So the mimicking or sounding like a human, these errors would be pretty minor if the only point of a chatbot is mimicking human speech or communication. That's pretty okay. I mean, it's not okay, but the consequences would not be super extraordinary. But the companies designing and using these bots have grander plans. Chatbots could replace Google or Bing searches with a more user-friendly conversational interface, or assist doctors or therapists in medical contexts. In these cases, accuracy is important and the errors represent a serious problem. So this is where we are, because no one is using ChatGPT just for the sake of interacting with it, having a conversation with it. We are using it because we want to deliver something. There's a task that we have that we need to deliver, so we use it, right? So we are more on this bottom part of it, right? So how do we get out? It's the question. So some come say, well, calculator for words, it's a nice metaphor because it captures the what they do, which is to predict the next word within a context window. But they're not really just calculators for words. And one reason being that we see that they are confabulating, hallucinating, or giving us bullshit because they are mimicking what a human would sound like. So they're not calculators for words, Busey tells us. A calculator has a well-defined, well-scoped set of use cases, a well-defined, well-scoped user interface, and a set of well-understood and expected behaviors that occur in response to manipulations of that interface. Large language models, when used to drive chatbots or similar interactive text generation systems, have none of these qualities. They have an open-ended set of unspecified use cases. So he's got a point, right? So it's not like a calculator where if I know how to use a calculator, I am going to get the results that I need that are going to be accurate, right? So there's not a lot of scope for uncertainty to occur in the interaction between myself and the calculator. So that's the point that he's making, right? So there is all of this scope that is coming from interacting with large language models that is beyond that certainty of interacting with a calculator. So how do we understand then what large language models are if they are not calculators for words? Okay, then Andy Bayo also said that calculators always give you the same answer for the given input, and large language models don't. So if you run the same prompt through a large language model several times, you'll get a slightly different reply every time. And I'm sure that you are aware of that, right? So there is this sort of like a phenomenon that is known as stochasticity within these models, such that they will produce different answers every single time. So then we can agree that maybe calculator for words is a bad metaphor. Maybe it's onto something, but it fails to capture other aspects of large language models. And this is a bad metaphor for the use of these tools because of the opacity of the function of a neural net. And this is known in computer science as the black box problem, which basically means that we have absolutely no clue what happens between the input and the output. That's the black box problem. So that's the opacity or black box problem. We have no idea what happens between the input and the output for the large language models, but we do for the calculator, right? And then the lack of reliability versus the calculator. The calculator is very reliable. A large language model isn't. Confabulates, hallucinates, gives us bullshit, right? So it's not reliable. So there are these distinctions between calculators and the large language models. And also, we can agree that calculators are not artificial intelligence, right? Okay, so now what are large language models? How do we get out of it? So not calculated for, so arguments for it being calculators for words, we can understand why, and arguments for it not being calculators for words. So what are they? How can we understand them, right? Such that we are educated, we are informed in the ways in which we interact with them, and in ways in which we integrate large language models in everything that we do, be it academia, research, businesses. It doesn't really matter. Okay. This brings us to the second part. So now that we have destroyed all of the hype, how are we gonna build something out of it? So the discussion bit that will get us moving is, if nothing else from this presentation, large language models are not search engines. I know that many of us interact with them as if they were. I know that Google is just now out the Google Pixel 8, where instead of Google itself, you have a Google with the large language models. So this is where the world is going. It's such that you have large language models that are integrated within the search engines. But are large language models in the business of giving us facts? No. So that is terrifying. That is horrible, right? This is it. This is the large language models are not search engines. Okay. Even if we don't have a good metaphor, even if we don't have a good understanding of what they are, we know what they are not. They are not search engines. All right. So calculator for words is an excellent cautionary metaphor that we can, tell our peers, tell our friends, tell our people that they are kind of like a calculator for words, but not entirely, right? Because they are alienated token prediction kinds of things. So then we can say that they could be calculated for words. But then it attacks the idea of large language models. And it attacks also the idea, thinking about it as calculators for words, attacks the idea of it being like, these search engines. So that's the thought. And yet, here it is. This is like from 2 days ago. So I just sneaked it into the presentation. This is from 2 days ago. We have Perplexity, who is startup Perplexity, wants to upend search businesses. News outlet Forbes says it's stripping them off. So this is a big media scandal just 2 days ago, which is precisely companies trying to peer and collaborate with search engines such that large language models become the new search engines. And by virtue of what we've just been discussing, that is something that we probably would want to push back on. All right, so why not calculators for words? Well, the true issue becomes that of utility, okay, which now is where we get interested because we want to know, is it useful for me? Shall I be using it? Shall I be incorporating? Okay, so there's an issue with the utility, which is both C is correct in attacking the calculator for words as a metaphor, not only for the reliability, it's not reliable, it is an uncertain outcome, it confabulates, it hallucinates, but it also becomes because we have this insufficient understanding of these black boxes. So imagine now that we integrate all of our search engines with large language models, and we want to understand how do they deliver a certain output. We can't because they are black boxes, right? And all of the other reasons that we already discussed. Okay, so what would be a better metaphor? So I've been thinking about this with colleagues of mine here in Macquarie. What would be a metaphor that I can come to give a talk to anyone, right? And that we would get to the understanding of what they are, whether they are tools that we can ethically use, right? And if so, how? Right, okay, so
if not calculator for words, because of the high level probability inference, they don't have that. They're not search engines, we just said that, because they haven't certain outcomes and confabulation. Then what would be a better metaphor? We start off with this thinking. So this is work that I've been working with Brian, that is a solutions architect at the digital humanities in the Faculty of Arts. And what we come up with to understand it in a better way is that the large language models, and let's see if this makes sense. A large language model is a map with no territory. And I'm going to unpack that. This suggests that using a map that has some signs but has no territory, so there's no sign referent to it. It's a map without a territory. And let me try to unpack that a little bit. Something like that. It stores the representations of statistical relationships between tokens. Because remember what we said. How do they operate? They predict the next word within a context window, right? So they have these tokens that they use, words that they use as tokens, where they predict the next word. The relationships stored in the models are a map with no territory. And in our map metaphor, we call them traces. So those are traces. These are things that we can understand that they are there. Whether they map to something in the reality, probably not. Because that's not a large language model's business. It's to look like it, right? So a trace would be something that is a correspondence of a sign or a token output by a large language model, which has a referent that could be useful, but that usefulness is going to be coming from the user, us. Okay, so then we have to master the technique. So it's not like we are all ready and prepared to interact and use these large language models without having skills to do so, okay? Because they will confabulate and we will have to make certain decisions. So we need to have technique to be able to interact with large language models and integrate them in an ethical, safe way. The skill of using these tools, the core of the technique is that of navigating between infinite maps. So that's the kind of like the metaphor kind of thinking. So what happens is, in more detail, that a large language models is going to produce those tokens. This is not news under the sun. We said it predicts the next words, and the words are tokens because the large language model doesn't really understand or go by words, right? So it produces tokens that are based on likelihoods. And remember what we said, these are likelihoods that they don't even have to be the most correct one. It's just the one that appeared the most or was most likely in the past. So they produce tokens based on likelihoods of all of the preceding tokens in a certain context window, in a certain topic. An effective metaphor will then establish how a user can populate the context window so that the path of least perplexity is the path with the output that they desire. So the path of most certainty, least perplexity, most certainty. There would be a good use, a good skillful way use of interacting with a large language model. And that's of course going to require certain conditions. So what happens is that we have an input, which is us. We are the input, and the input is the starting point. And that's exactly what the calculator, as the metaphor, is doing. It's telling us, well, it kind of like starts by looking like as if we were interacting with a calculator. So the input looks like the calculator. We input something and we want to get some kind of like output. Now, what happens here in the middle is something that is not calculator-like. Because what happens in the middle is that there is a large language model black box with opaque decisions that we do not understand. And if we do have businesses and companies that are integrating these kinds of models, and we are called up to explain why we came up with certain output decision and integrated that, we will not be able to be accountable for that or to explain how we came to that because of the black box problem. So this is a real world problem in ethics of AI. And then we get an output, and the output is that of the Botsy refutation. So the output is going to be something that is highly unpredictable, most likely unreliable, and most likely a confabulation. So that's how you connect all of these things between, it looks like a calculator for words. There's a black box problem, which is ethics of AI, right? We need to explain how did we get into the output, which is most likely a confabulation. Okay, so then how do we get out of this? How can we understand those tools such that we can use them properly? Okay, so it's a map with no territory. That's the first thing to understand. It's a map with no territory. It's not giving us facts. It's giving us something that will look like it's a human chatting to us. So a large language model is a manipulation of tokens. These are signs that are divorced from referent. They have no referent in the world. They present infinite maps with traces from many territories, okay? But they do not make that connection for us. A successful user, us, hopefully in the future, a successful user can use these traces to develop effective mental models of the tool and enhance their techniques and have more real-world desired objectives. So a successful user is not someone that is just going to take at face value whatever the output is going to be, because a successful user is someone that knows that most likely what they're getting is confabulation. So that's already something. So those focusing on the tools themselves, just on the tool without understanding what these tools are, just focusing on the tools themselves or hoping that the generative AI will handle territory outputs, which they don't, misunderstands that large language models are maps with no territory. They are mistaking the map for the territory. Somewhere lost around here. Okay, there might be some usefulness of this drawing that we may take some traces from here and apply to the real world, right? But this is a map with no territory. There's semantics in there, there's meanings. We can recognize things in there. They connect with each other, but there's no link with the territory. So that's the thought. All right, so then this brings us to the last bit, how to use it well. And I'm going to tell you about how we can do it. Okay, so the first lesson is that you are responsible and accountable for all of the outcomes of your AI-generated content. So that's the first thing in ethics of AI with LLMs. You are responsible when you generate an image and you attach your name to it. When you generate a text and you attach your name to it, that's yours. You own it. You are accountable. You are responsible for it, right? And now you know that it may be confabulation. That will be your confabulation. So that's something to think about. So when we use large language models, the use you make, accepting, rejecting, a use, a misuse of a map is of that of a map with no territory. And your name is going to be linked to it. So that's the thought. So if we are to navigate these large language models as infinite maps with no territory for a certain desired ethical outcome that you want and need and wish, then it requires certain conditional skills. And we took inspiration on The Library of Babel by Jorge Luis Borges. Who knows this book? Okay, so let me define the book for you and you'll see exactly what we mean here. So this is a definition of the book. A universal, and I added digital, library containing books with every possible combination of X words in a context window, thus containing every book that ever has been and every book that ever could be written, drawn by an immense quantity of nonsense. So what's happening here is the analogy is a repository, a digital one, that contains everything that may have happened, everything that has happened, and everything that could happen. So when you engage with large language models, expecting them to give you facts, they're going to give you an assemble of what could have been, what is, what may have been. That's what they're going to give you, right? So that's the analogy with the library of Babel. So Babel librarian, let's think about, now we have this Babel library. A Babel librarian is going to have a very, very, very hard task. Because if I get to the librarian and I ask, give me the facts, that's going to be really hard for the librarian to do, right? So that's what we need to do. So a Babel librarian is skilled to determine which book is accurate and point towards potential real world territory, use of the knowledge in that book. Those are the skills that we need in order to interact, engage, use ChatGPT or other large language models. We need to be that Babel librarian. So the person interacting to derive utility needs to have certain kinds of skills. What are they? Capability, the ability to set up initial conditions such that it is possible to succeed. So technique with the tool is one of the conditions. Knowledge, a fundamental awareness of the subject matter, much like a reference librarian, enough to recognize and refute bullshit. Expertise, the ability to curate the responses through these infinite maps, those kind of like real world merging with the illusionary world or the world that could have been. So then the question becomes, how should we integrate these kinds of AI, generative AI, large language models, ChatGPT with or within our businesses, our organizations, our universities, our research, with knowing that all of those are going to have social impact, right? Okay, so let's say, for example, if we integrate large language models, confabulations, and snowball effects, for example, in healthcare, the consequences of that are very well known in the literature, and I'm happy to provide, if you'd like, misdiagnosis, inappropriate treatments, or harmful medical recommendations. Because remember, it's to mimic a human chatting with us, right? Education provided students with incorrect facts, flawed explanations, or biased perspectives, which undermines their learning and critical thinking skills and community flourishing. In law, incorrect legal interpretations, flawed cause assessments, or biased recommendations, potentially resulting in unjust outcomes or miscarriages of justice. Wealth distribution, skewing financial strategies in favor of certain groups. This can lead to an uneven distribution of wealth, where marginalized communities might receive subpar financial advice, further entrenching existing inequalities. And these are just the most obvious ones. So then the question for us, if we want to engage with large language models, is going to be, how aware do we need to be in order to accept an output and to use it in the real world? Yeah.
We use a lot of AI in our company, and we're building AI for the military as well. I think one thing that's probably worth mentioning how we use it is, rather than going to the large language model for facts, we give it facts, and it helps us produce things like a response to an email, some marketing documents, but we're feeding it facts, and then it can then summarize that in a digestible format. So it's not just about going to that looking for answers. You can feed it a ton of context. Like when I use ChatGPT, I'm putting in 20, 30 pages of context to get out, a LinkedIn post. So there's different ways you can use it. I think that's something I didn't hear today about using that fashion, but I think what you said was right about, applying discretion when using it. Like the output that it gives me, you have to fact check it. You've got to read it. You've got to make sure it makes sense. Like I'm the expert, and I'm putting that out. That's attached to my name. So I think it's there's a ton of different ways you can use it. Even responding to emails, I'll copy and paste a large email from the politician, and I'll say, mate, respond to this email with these 10 key points, mention this, be empathetic, do that, and it'll draft it. It's so much quicker to edit that email than draft, spend an hour on email, if that makes sense. Yeah, so it's a time-saving tool, but you've got to be specific, give it the facts to what you want. That's how we use it.
Good example?
When you're sending information through responding to,
Yeah.
do you find when you fact checking there are errors in summary on fact what you put it?
It rarely gives errors on summaries of facts that I've given it or what I've told it, because it's summarising specific, I've given it specific instructions. So we have products, this is how the product works, this is what it does, this is the benefits. But if you ask just a random question, how does that see work? It's a wild crowd. Yeah, so I think just for us in our company, that's how we use it. So like I said, we've got a central repository that's literally in Word docs, and we just copy and paste everything in there. And that repository is like hundreds of pages of context. So and now that saved our company so much time. So we had a LinkedIn post today, which ordinarily that would have taken hours to draft this, 20 minutes. Change the spelling a little bit. A bit of everything, yeah, but it's much easier to be an editor than an author. Yeah. So let it help you be an editor. And you can author, you can do the heavy lifting, if that makes sense.
Right, can I contextualize it? Okay, so when you said about the conditions, there are ways in which we can use it. There are higher stakes, and other things that are lower stakes, right? What happens there is that you are a subject authority on the matter. So that's how you can evaluate the outputs. So that's a very low risk kind of task, which is why the goal of the presentation is not to say don't use it. It's to say that you need to have certain skills such that you accept what comes back as, oh, this is actually pretty good because it's summarizing and you are a subject authority.
Yeah.
So you've got the librarian skills.
Yeah.
So that's the idea there, is that there are certain conditions that apply for us to make good use and application of large language models. This is a good example, right? It's the same as when you would ask a large language model to give you your biography.
Yeah.
There's no one else that is a subject authority on that matter other than me. And yet, all of us are going, this is pretty inaccurate because we are a subject authority. We immediately spot bullshit. Right? So being a subject authority is one of the conditions. It's not sufficient, it's not the only one, but it is one of them. And this is a good example.
That's massive. I think it's your point. What I thought was a great presentation by the way, even though we said start great presentation. But again, I've asked things, the whole bit, as a lawyer, reviews this document, what's your recommendation? I look at it, it's using all these fancy words like subpoena and bloody whatever. Then I get my lawyer look at it, she goes, this is horrible. Like it's just, so if you are a subject matter expert, you realise very quickly that this is not an expert. It's
Precisely. Yeah.
It can be very useful for setting up a frame. And even though it might be all frameworks there, often the framework is that we do.
A framework for?
Or say for an essay about something like that.
Could be. Let me use this example. To set up a framework for an essay.
Yeah.
So an essay, we want to write an essay because we have something original to say.
Yeah.
Something that doesn't exist in the world. Right. So that's why we want to write an essay. So when we ask that from a large language model, typically we are interacting with a large language model that is a free of subscription, so it's all the knowledge is until 2021, and we're asking it to go back to the past and tell us from the past what would be a good essay to write, right? So there are limitations with that in the sense that it is not, we're not talking about an agent that is present in the future and has got an understanding of the state of affairs and is going to act upon that understanding of the state of affairs. What it is going to give us is the likelihood of certain things coming together with other things in the past, right? So even for that essay framing, it can help us as a ladder for us that are in a path of learning can help us as a ladder, but I don't think that in the end that's what we would like to be doing. It can be used as an exercise, like, oh, okay, I understand this is the kind of structure that I can have. But originality, right, something that we want to bring into the world, we need to then together. This.
Steps along the way, and some of those might be incorrect, and you can take those out, but at least it takes away having to think, oh, how am I going to do this? You can ask it, and ask it several times, and give the ones where you're using values, that you're using, and it'll come up with this, oh, that's not much to do that.
Yeah.
That's how I use it.
You would have to be the subject authority to make those decisions.
It's just helpful to provide something for you to, it's part of this reflection.
Yeah,
And some of those bones might be incorrect, and if you can correct that along the way.
yeah.
I might wrap us up there because I feel that we could keep debating for ages. Thank you so much. That was so insightful. Hilariously, you're 100% right. The computer overheated. So it's totally taking rebellion upon us chatting AI and being critical about it. Thank you so much for your time. If you want to get in touch with Ines, her details are here. And one more quick thing that I wanted to bring to your attention is Ines is one of our founders in our cohort this semester of 20. If you would like to meet the rest of them, we are having a demo day here on the 25th of July. You can come and hear from more of our founders doing incredible work like this. But thank you so much for coming. Enjoy the rest of your day. Thank you.